me go ahead and do that now. You saved me so much trouble, right? All right, so yeah, we said that our formula for Hooke's law is F equal kx, right? And then our force, we have our spring constant already as 2.0 times 10 to the 5. Now we need our force. And the way to find our force is using F equal mg, right? F equal mg. Now m here is 1.2 tons, but we need to convert this now to kilograms, right?
Yes,
Kilograms,
sir.
right? Convert to kilograms. No
I thought 12.
kilograms, right? Not the best handwriting. Let's add this person, right? So 1,000. How much is one kilogram in ton? How much is 1 ton in kilograms?
1,000.
Right. I just said it a while ago.
One to
Right. Sorry about it. So 1,000 kilograms is equal to 1 tons, right? Now convert 1.2 tons to kilograms x. We must then cross multiply, right? Cross multiply. So what are we getting here? 1.2 times
1,000.
1.2
1,200.
times 1,000,
1,200.
right? Yeah, 1,200 essentially equals x, right? X times 1, x. So our mass now is 1,200, sorry, 1,200, 1,200 kilograms, right? 1,200 kilograms. Now we need our gravity. What is our gravity? G. What is that?
10, sir.
10 or um it's in the textbook,
9.8.
right? 9.8. What is essentially 10, right? If a question tells you to use 9.8, please use 9.8, right? All right, so what are we getting here? What is our,
11,760.
all right, so I see we were at a long time. Let me just double check. 11,000. All right, this is not working either. Give me a second. 9.8 times 200. Right, so you are correct. 11,760 apples, right? Or
Yes,
11,760 bread. What is our unit? Unit is what? What is our unit again?
kg.
No, kg is how
And
much?
Newton.
Newton.
Right,
Newton.
right. Newton. So this is our force. Now we have our force and we have our k. Now we're going to find our extension. So we want extension on one side. How do we get extension on one side? How do we go about getting extension on one side? Transpose, right? We're gonna transpose. Hello?
Okay, all right.
yes, sir.
Yeah. So what we're transposing, what do we want to get rid of?
The G.
No, in this equation here. Sorry. In this
Decay.
equation, the k, right? Want to get x on one side alone. So what do we do?
Bring the G over.
No, in this case, in this formula here, we're calculating the extension now, right?
Kg.
Just focusing on this equation over here. So we have f equal kx. What do? We want to get x on one side alone. We want to calculate extension. How do we do that?
Trans.
So we're going to move the k, right?
Yes, sir. Move
So
the
how would we
case.
move it?
Bring it over the equal sign.
Right. And how exactly would you do that? Multiply, divide, add.
Divide, sir.
Right. So we divide both
Divide f
sides
by k, or divide both sides by k.
by k. And what will happen to these two k's?
They're gonna
They would
cancel.
be cancelled.
Right. They're going to cancel. So then we're going to have x equal f over k. So we are almost there. So our force is, remember our force? All right. Our force is 11,000.
11,600.
Right.
So what? Yeah, 700.
760.
That's our force. And our k is up here, right?
5,880.
Let's take it one step at a time, right? So we have our spring constant, our k. Now we know about standard form. We know how to change standard form to regular form. We know how to do that. So we have 2.0 times 10 to the 5, right? So if we convert this to regular form, let's just put this down here. To the 5, convert this now to regular form, we would have say 2.0. So we have 1, 2, 3, 4, 5. We'll do more standard form, right? It's because we don't have much time left. So now we have 0.0002, right? So somebody place this in their calculator for me. No, I am completely wrong. I am completely wrong. Right. Sorry, 2.0, and then right in this direction. We'll do practices. It's because we don't have much time left. We can do practices with standard form in the future. Right. So 1, 2, 3, 4, 5. Right. So somebody plug this into their calculator for me. 200,000. All right, somebody plug this into the calculator for me.
Sir,
17 point.
588.
So 0.0588.
588.
588.
Right, we can leave it at 559, round up, right?
Yes.
So just get that again. So we can look as I said, we need some practices on standard form, working with standard form. Inside this person. We can look on it in 5 minutes. So 0.59 meters, right? That's our extension. All right. Now, are we understanding this? We're going to look on standard form, but are we understanding this?
Yes.
Right, we're good on this, right?
So,
All right.
sir, question.
Yeah, question.
The only time you want us to round off is when we get the answer, right?
Yeah, to make it more presentable. You don't want 0.598888321 for your answer, right? You want maximum 3 decimal places, right? 1, 2, 3. Right? You don't want to have 0.5988234 as your answer, right?
Okay, sir.
Yeah, we're going to look on standard form. Let's right? So, all right, as it relates to standard form, right, we can do a quick little run through of that before we go. Standard form. So we're saying that are we familiar with standard form? Have we ever heard about it before?
Yes, sir.
Right. So I'm going to need the help then. Right. I'm going to need the help. So convert this to standard form for me. What would you get? Right. So we have decimals. Right. We have decimal places. So
2 times 10
2
squared
times 10
cube.
cube. No, we're missing something.
Sir, is it supposed to be -3, sir?
Right. -3. Right. So because we're moving from say in the decimals to actually
Right to
whole
left.
numbers, we're going right, we'll
Left.
need negative, right? But if we were converting this to standard form, we are going from whole numbers to decimals. So decimal
That
to
would be
whole numbers is negative, always negative. And whole numbers to decimals, you have a positive exponent. So what would this be?
Sir, second
times 10
right and then
per
on
unit.
right to left opposite.
Yeah. So it depends on how you remember it. Um, so from, as I said, from right to left, positive, and from left to right, negative, right? Try and remember it that way, right? But supposed to mix them up in the exam when the pressure gets on you, right? You don't want to really mix them up. So
Sir, ever
um
since you didn't teach me, mix me up.
well um not all of us are are that good at it, and so obviously it might take some practice. But for me, I just know that when I'm moving from decimals, anytime I deal with decimals, I always do negatives, right? And anytime I'm dealing with the whole numbers, right, you have to do positive. I will make some standard form exercises. I'll put some standard form exercises tomorrow. So we won't have a full class tomorrow, right? We'll just come on and discuss this question, right? We don't want, I'll probably just post a video in the group or something like that, or post a video on Google Classroom, right? We won't have a full class tomorrow, right? And this is just an exercise. So we completed this, right? And we're good. Are we good on this before we close? Are we good? Any questions, any concerns? All right. I'll take that as a no, right? So as I said, I'll make an exercise with some standard form exercises so we can get a little more practice in standard form, right? So that's it for today. We completed a lot. We completed a lot today. All right, so all the best, everyone.
You too.
All right.